Hello, everyone. This is Michael Schachter from Allot. I'd like to welcome you all to another Allot webinar, and this time we will examine the 5G hype phenomenon, and we will drill down into some of the underlying technological challenges. As I'm sure you all know by now, Allot is a leading provider of innovative network intelligence and security as a service solutions for service providers and enterprises worldwide. We've got an exciting 5G presentation today. The main presenter will be Itai Weissman, who is our vice president, and he will go into several aspects of the technology that we think it's important for communication service providers to look into and think about as they're designing, building, and rolling out their 5G networks. You know, like any other new technology, the hype is kind of overblown, but we think that, and I'm sure you all think that, unlike the transition from 3 to 4G, we're looking at a revolution this time and not just an evolution. And there are things that need to be taken into account. And that's what we're going to talk about today. A couple of housekeeping items before I start. The webinar is being recorded, so you can access it again. You can listen to it. You can share it with colleagues. So we welcome you to, visit our website to look at the recorded version. And comments and questions are welcome. So there's a Q&A chat box. Let me know, maybe a couple of you that you actually hear me, which would be good to know. And there are some widgets at the bottom of your screen that should have some links showing you different pieces of collateral and other information that you might want to take a look at. Okay. So let's get started, and here we go. So first, just so we can get some context, I'd like to ask you all to answer a quick poll question, letting us know what kind of CSP you are. Are you fixed, mobile? Are you converged, or actually not from the telecom, datacom, ISP world, but more of an enterprise? So let's take a second to take a look at that. And okay, I will submit your results and we'll have a sense of who's out there. Okay, so we've got a third converged and 2/3 enterprise. Very good. Let's keep it moving. One more follow-up just to understand who you are within your organization. If you could tell me, are you more engineering, marketing, operations, security, or did I miss a category? Let me know. Okay, let's see who you are, and let's take a look. Okay, 50-50 between engineering and marketing. That's good because there are topics that will appeal to each of you, I trust. So the 5G silver bullet hype, right? That's what we're here to talk about. Is 5G, this telecom, datacom silver bullet, is it going to solve all of our problems? Is it going to help with revenue? Is it going to help with time to market and reducing cost, operational efficiencies? What are the new use cases, and what are the supporting technologies that are important to understand moving forward? So again, I'm Michael Schachter from Product Marketing, and with me is Itai, the Vice President of New Markets and Innovation, and he will take over the main content of this moving forward. Let me just ask another quick question as we move forward, and that is, where do you expect to make money first from 5G? Is it going to be from things like autonomous vehicles, fixed mobile broadband to the home, just a better pipe, but it's mobile this time? Connected utilities, the grid, electricity, water, and so on, monitoring remotely, automated factories, or perhaps rolling out private enterprise networks to different industries like hospitals or universities or factories, fleet management, that kind of thing, or something else altogether. Let me know what you think about this one. And the answers are fixed mobile broadband to the home is the dominant one for sure here. And then private enterprise networks is very interesting, and autonomous vehicles and others. And if anybody wants to add in the Q&A what they think about the others, I'll be happy to hear that as well. So I am now going to turn over the presentation to Itai. And Itai, hopefully you see the screen, and hopefully the audience sees the screens. So take it away.
Hey, hi everybody, nice to meet you. As Michael mentioned, my name is Itai, and I'm in charge in Allot on new markets and new technologies to approach these markets and new solutions to these markets. And part of what I do is managing the 5G effort within Allot. So in this presentation, I'm going to review the incentives around 5G, the main concepts of how to address the business need, and some problems that operators may encounter addressing these business needs and how they can be solved. So the first, let's go back and think about what was the reason for 5G? It was not yet another 4G with bigger, better, faster, more, but there were actually some key items where operators wanted to address. Obviously, there's always the revenue increase and the decrease of cost, but specifically within revenue increase, the CSP wanted to become to make their network part of the software as a service value chain. And what does it mean? It means that if you are an application vendor, they want to sell SLA-driven business models. So you need a specific SLA for your application. For example, you are a car-to-car manufacturer, and you want to ensure very low latency between cars when you are communicating. The CSP wanted to make sure that the network is capable of delivering it. On the other end, if you are a video streamer like Netflix and you are counting SLA in a completely different manner, the network needs to deliver to be able to deliver that as well. And this is where many times you hear the phrase SLA-driven networks, then this is what it comes to represent. Second is that the CSP wanted to become part of the cloud game by leveraging on partnership with software as a service vendors. So, for example, again, if you are somebody that is doing automation of manufacturing floors, you need very, very fast reply from your server, very low latency, when the server connects to the devices on the manufacturing floor. Today, it is extremely difficult to achieve it. You have to deploy your server at the manufacturing floor. That's very costly. What the CSP wanted to do is, okay, allow you to become part of his network, deploy the server as part of his network, and assure you a 1 millisecond latency. So that's a way for him to become actually an infrastructure as a service provider and become part of the software business rather than just the connectivity business. The third aspect is the IoT focus. It's no secret, the IoT is booming. CSP wants to become part of this game, and the network is built to deliver different type of services to different type of IoT devices. It is built in a way that to assure that communication is the right communication for different IoT devices, and it is also providing a lot of APIs for fast and reliable IoT management. So you don't have to do the IoT management by yourself. You can simply use the service from the CSP. The other aspect is the reducing cost and reducing time to market, and what the network is doing here is that it allows flexibility in the service deployment. And the first thing is the network is completely cloud native built. Okay, so you can, just like in Amazon, you can bring up, tear down, scale in, scale out services across the network at any place that you want across the network. For example, if it's important for you to have low latency, you will deploy it at the edge of the network. If you just want centralized, you will deploy it at the core of the network. But the network is fully orchestrated, fully cloud native, allows you to do all of these things. Another thing is that there are the increase in capacity or in the radio capacity comes also with the increase of backhaul cost. And this cost needs to be managed somehow. And this is done by deploying mobile edge. Okay, so basically the network now can deploy the core, the network core, all of the core functionality anywhere in the network it wants, and allow direct internet access instead of hauling all of the traffic all over the country. And the last item that is used in order to control cost is to leverage on content partners. Content partners are, for example, Netflix or YouTube or any other video streamer or gaming vendor, where the network allows, for example, for generic caching, and it exports interfaces for caching to the owner. So basically, the Netflix CDN or the Google CDN can go all the way to the network edge using standardized interfaces. And it plays well to the service provider as well as to the content owner. And through the service provider, it reduces the amount of traffic that needs to come from the content owner because he has it on cache. And for the content owner, his subscribers get better experience. So in terms of use cases that were defined, there are three main use cases, and the network that the network is allowing, and all the range between them, and you can mix and match and create all the range between them. So you have the typical enhanced mobile broadband use case where you have it's bigger, better, faster, more. Okay, bigger speeds up to 1 gigabit per device, but essentially the same concept as today. But there are two new use cases. One of them is a massive IoT or massive machine type communication, where the idea is to support a massive amount of devices per square kilometers. It's over 1 million devices per square kilometers at ultra low cost. These are devices that will generate very low traffic, but you need to support a lot of them. Okay? So this is another key use case, and it has very specific characteristics the network needs to support. And the third one is ultra-reliable, low latency communication. This is all the car-to-car manufacturing flows. These are devices that need immediate response time, and they need to make sure that the communication is ultra-reliable. You don't have any message loss. Now, in between them, the network can mix and match. And if you are using augmented reality where you need higher throughputs, but you also need relatively low latency, but you don't need ultra reliability, the network knows how to provide that as well, as long as you are on this range. And in order to accomplish all of these use cases and this flexibility, some key technologies were adopted at the network level. The first is network slicing, where the network can think of a slice as a virtual end-to-end network from the radio all the way to the service that allows you to define your SLA parameter. So, for example, you say, I need to guarantee 100 megabits per second. I'm augmented reality, 100 megabits per second per user, and latency of under 5 milliseconds, and I need assured delivery of messages, for example. Okay? So the network is now building and assigning resources for you from the radio all the way to the core in order to assure this, this delivery. And it is measuring it. It is measuring the resource usage, and if there is need, it will increase the resources that are needed. If there's no need, it will decrease it. That's the concept of a slice. Every slice can be tailored for very specific SLA, in concept at least. The second is the edge computing, where you are deploying the network with all of the facilities, all of the core, as close as possible to the edge, and we're talking about sometimes tens of mobile edge compute nodes in a single city. And the mobile edge compute is a kind of a CSP cloud, where the network itself is running, but also it can host services and applications. Caching is one of them, IoT gateways, and other services. The idea here is that when you are deploying close to the edge, you can provide low latency and reliability, but you also save on transport costs. So, for example, if you have traffic that needs to go to the internet and it's a best effort traffic, you can go to the internet directly from the mobile edge rather than send the traffic all the way to a central core. The last thing that was done in terms of architecture is that there are many user plane elements that were used in 4G. In 5G, there's just one user plane element. Okay? It's called the UPF. Instead of having many elements with hierarchies between them, a UPF is the only element that is actually managing traffic in the 5G network. And it has the unified capabilities of all of these user plane elements combined, which allows for a much higher flexibility in terms of the overload. But the dream does not come without its challenges. I mean, all of these concepts are great, but they do create problems, some with execution, some with new threats that are coming. For example, if you're going to allow for millions of IoT devices, then your internal attacks, IoT devices, are susceptible to being penetrated by security threats, and your internal attack surface on the network becomes massive. They can launch DDoS attack. They can also launch signaling attacks, which just disrupts the network operation. Slicing. It's a concept that allows you to deliver SLA, but it's still the SLA is measured in old world terminology. It is measured by KPIs, latency, delay, throughput. This does not represent the quality of experience that your user is getting. Your user may be an actual consumer that wants to see Ultra HD video, and nobody knows, according to bandwidth or latency, whether he's actually getting the Ultra HD video. And the user can be an IoT device that needs to have 100% of the messages delivered within a certain time. Okay? Slicing does not guarantee it. It counts things that in theory can be indicative of QoE, but they are not actual QoE. Monetization there's no silver bullet yet for how to make money of all of this investment. IoT is not yet living up to the promise. It might in the future, but there needs to be a way to monetize immediately on this investment and not just build on the future. And there are many hidden costs when you're talking about distributed architecture, and we'll discuss some of them later.
So we have another question coming up, and Itai, kind of hinted at some of the challenges that operators will be looking at. And this first question is about operational concerns. So the questions here are, what's your biggest concern looking forward? Is it going to be keeping 4G alive and high quality while you're devoting your resources to moving to 5G? Are you going to be most concerned with the vulnerability of 5G due to the expanded IoT attack surface, which Itai hinted at? That distributed architecture that he mentioned has to do with things like the cost of transporting from the edge to the core, and we'll hear some more details on that as well. Part of 5G and the whole architecture has to do with NFV and virtualization and the ability to scale, to meet demand where and when and where in the network it's needed. Are you worried about whether NFV can really live up to that? Lack of visibility into the quality of service. So Itai again hinted that typical or traditional KPIs don't necessarily indicate the end user's QoE. So that's something that may be of concern. Or you may feel this is the 5G telco silver bullet and we have no worries. Everything is going to be fine. So it's a bit of a long list, but we'd like to hear what your biggest concern is. And while you're answering that, I do just want to remind you that on the right of your screen, there's a window by which you can send us an email with a specific question that you'd like us to handle offline. There's also a list of resources, links to some additional information that we think will be helpful around the subject of 5G. And at the bottom of the screen, there's a red link widget, which also gives you easy access to relevant information on the Allot website. So, okay, let's take a look at how you responded to your operational concern question. And, well, a lot of concerns, pretty well evenly split. With the slight lead going, no, it's a tie for first place between the vulnerability to attacks and the cost of transport. And, two very legitimate areas of concern. I think Itai is going to touch on most of these going forward. So I'll turn it back to Itai, and here we go.
Okay, so as we mentioned, 5G does bring some new challenges. One of the big challenges is the security threat, and there are many of them, but I will focus on something that is inherent to the architecture, and that's 5G is the mobile edge compute concept in 5G is very strong. It's aimed to ensure some of the network services, and there will be a lot of mobile edge computes. But these mobile edge computes, they are susceptible to attacks. And why? First, it's a new intrusion point to the network. And a mobile edge compute, most of the elements, most of the applications running there are trusted applications, and they have a connection to the internet. Mm-hmm. So in the past, you did not have any applications running in a mobile inside a mobile core that have a connection to the internet. The application themselves were segregated from the internet. Now, by definition, they are connected to the internet. So all types of malware attack, application level attacks, and things like this are now open. But not only this, but also denial of service attacks can be launched at a specific application. And when a specific trusted application is impacted by denial of service attack, it can impact core components within the network. For example, it can create a signaling storm within the network. The mobile edge compute, not only the fact that it has an internet connectivity and trusted application running on it is a threat, but the mobile edge compute is not built to scale. Mobile edge compute can be as low as 5 gigabit per second of capacity, and as far as we've seen up until now, the biggest ones are around 70 to 100 gigabit of capacity. It's very easy to launch a DDoS attack against such a relatively low capacity port. So it is susceptible. The mobile edge compute brings new threat from the internet. The IoT, the whole concept of IoT and the vast amounts of IoT and the mechanisms allowing for vast amounts of IoT are creating a new attack surface. And this new attack surface is now actually a new type of attack surface that is attacking the network from within. Basically, the perimeter of the network has changed. In the past, you protected DDoS from the internet to your network. Okay? But now, the actual the DDoS attack can come from within the network, and it may not even be targeting your own network, but a massive botnet might attack an external resources. But because they are doing it through your network, they are killing your radio, your backhaul, your mobile edge, and basically blocking the service in your network. And it's not only that there's massive amounts of them, but in theory, every device can get quite a lot of, can use quite a lot of bandwidth. And so there are ways to limit it, but in theory, quite a lot of devices can use up to 1 gigabit per user. So it opens the way for very effective internal attacks on the network. The second aspect is that there is a need to sell SLA-based services, and for that slicing was made, but slicing is not enough to guarantee SLA. And why is that? First of all, because the resources at the end of the day are limited, and slice has an allocation of reserved resources for it. Okay? So congestion will occur anyway. I mean, at the radio level, if many people are using augmented reality or using even 4K videos, or there are just many people on this radio, congestion will occur. Okay? And the fact that you reserve resources is good enough for one slice, maybe 2 slices. But what happens then? Okay, you cannot create 1,000 slices, and at some point you will not be able to allocate more resources in order to manage the congestion. And in this case, you will need some other means of managing a congestion within the network and analyzing the actual QoE in order to manage the congestion.
Itai, let me just interject here. Quite a few people are clicking on the send a message to us. There's a space there to actually type in what your question is that you'd like us to follow up on. So we've gotten quite a few empty emails saying just the subject of request for more information. So it would be helpful if there is specific information that you could let us know what it is you're looking to hear. Thanks.
Okay. So as I mentioned, within a slice you can assign resources, but the more slices you assign, the bigger of a problem you have, because you are reserving resources that are not necessarily in use, and you are basically underutilizing your networks. So you are actually creating congestion. Mm-hmm. So when you start going into the realms of thousands of slices, you are most likely going into a situation where you have cross-slice congestion. Just the allocation of the slice created a congestion. And that's even a bigger QoE issue, because people are not really utilizing your network to the full extent. There must be a better way of doing it. Yeah. Yeah, Michael?
Sorry, yeah. I just was answering one of the questions. So we are up to a poll question? Yeah, okay. Itai has been focusing on the operational issues, things like the IoT fabric and the size of the threat, and if your Coca-Cola vending machines are suddenly turned into a bot and are attacking a bank, but going through your network, things like that. But there are also business model issues to consider, and Itai briefly mentioned that at the beginning. 5G is a tremendous investment, and you know that. And the question is, how is the industry? How are you going to make money? Where is the ROI coming from? And how will business models need to change or not? And so our question to you all is, how do you expect it to change? You don't expect it to change at all. You'll keep doing what you've been doing, but just bigger, faster, whatever. Or consumers will pay more just for having 5G because they're getting a stepwise boost in throughput and in speed and bandwidth, and so they should pay for that, and they will happily, because they'll enjoy whatever it is they're using the internet for more so. Or you will find ways to tailor new application-based pricing plans. For example, something like ultra-high definition for your video will cost more than regular quality video, and then you can opt as a consumer to pay more for that quality, which is now going to be more possible with 5G. And here's a nice payback to the OTT world. Application vendors like gaming, for example, and I know there's somebody here on who asked a question about gaming solutions. Those vendors will be actually willing to pay the CSPs, the operators, a premium to be part of their ecosystem, because they will be getting to customers who will be enjoying higher quality subscription to their games. So that would be another way. And maybe you're thinking of other things altogether. And so if you are, we'd be happy to hear about them through either the email or the Q&A. So go ahead and let us know what you think here. Okay, and what we hear is that it's by far application-based plans, being able to offer higher quality packages. It could be gaming, it could be sports when that comes back, it could be video, it could be a whole range of applications. So let's follow Itai as he takes us through some of those considerations.
Okay, so as you rightly indicated, the business model needs to change, and this requires a migration from the way of thinking of volume-based plans to something that guarantees quality of experience. And guaranteeing quality of experience is beyond volume, beyond bandwidth. It's basically creating plans that represent a value to the end customer. And this is exactly like the examples that Michael was just giving on Ultra HD. I can guarantee Ultra HD plan. Okay, just like Netflix. Okay, Netflix has standard HD, but you pay extra for Ultra HD. This is what but Netflix can deliver it. Okay, the reason that Netflix is selling it is because it can deliver it. Same way goes to the operators. They understand that volume does not mean anything anymore. They are all selling 100 gigabyte packages for peanuts. Okay, the users are actually, an average user is consuming less than 20 gigabyte. And yes, I know you think your kids are consuming 100 gigabytes a month, but the average user is consuming much less. And they are looking into migration, into value-based plan, and video is one of the main trends that we are seeing, guaranteeing video quality. Another challenge is the need to control transport cost. Again, you have a lot of traffic, so it costs more, even if the price per gigabit drops because of because connectivity prices are dropping, but you still have much more bandwidth. Furthermore, you have much more fibers. If you are deploying a lot of mobile edge computes, and now from every antenna you need to draw a fiber, that's a lot of cost in infrastructure. And this creates a new market for leased transport. Okay, so a mobile operator, I can give you an example of a very big one in Japan. About 80% of his transport are leased from a different fixed operator. That's a lot of cost, and they are not all the costs are the same. So, for example, if you have a mobile edge compute, accessing the internet through the mobile edge compute is relatively cheap. But accessing your aggregation, this is usually an MPLS link. This is or another type of VPN link. That's more expensive. Accessing the national data center with MPLS, which are MPLS links, these are even more expensive. So you need to be able to granularly control where every traffic is going. So if you have a best effort subscriber at a low rate plan, just send this traffic directly from the mobile edge to the internet. But if you have an enterprise with Zoom, for example, that you need to guarantee service to because they're paying you a lot, this traffic you need to send to the core where the Zoom servers are lying and where you have MPLS network that can guarantee service. So there is a big challenge on how to manage and control all of these costs in a way that is the most effective. So obviously, Allot is offering a way of meeting some of these challenges. And we believe that there are several key aspects that can be addressed by utilizing within the UPF technologies that combine DPI and security. So, for example, QoE visibility within a slice and guaranteeing the QoE within a slice. This is a use case for DPI. Backhaul, mobile edge compute backhaul reduction by steering traffic to the appropriate link, or it's another use case for DPI. Service plans. Obviously, DPI technologies can allow for service plans that represent value to the customers, like video plans, and they can assure the delivery of this video, and the network protection part, protecting mainly from botnets creation, botnets activation, and from DDoS attacks. Let's see how it works. So in order to assure QoE for OTTs over-the-top apps like YouTube, Netflix, WhatsApp, whatever, the first thing you need to be able to do is to correctly identify the application. Being able to separate YouTube SD from YouTube HD, WhatsApp call from WhatsApp instant messaging. And for every such application, you need to be able to analyze the perceived QoE by the end user, and this is different profile for every application, and that you need to measure in order to understand the QoE. It requires quite a lot of machine learning. Once you understand what is the perceived QoE, you need then to enforce a policy that assures that the perceived QoE is matching the expected QoE. And this is done by limiting, for example, of non-QoE affecting applications. This is done by, for example, by enforcing service plans. For example, a best effort service plan will only allow for 480p video streams. And then you need to make sure that indeed what you allow is only 480p. And keep on measuring the QoE and adjusting dynamically to assure it. Aligning the transport cost to the business model. If you are paid a lot for specific traffic and you need to assure the QoE by guaranteeing the link to the service, then steer it not directly to the internet, but steer it through the high-cost MPLS links. On the other end, if this is a best effort traffic, and a best effort traffic can be because this is just a subscriber that is paying for best effort, or it can be that the subscriber is paying a lot, but this traffic is not QoE affecting. So this traffic can go directly to the internet. And a high QoE traffic, or for example, gaming, a customer is paying for a gaming service. This will go directly to the nearest gaming servers via an MPLS link, and you will steer this traffic through this link. This way you can match the cost of traffic to the revenues that you get from it.
Okay, so we've heard a lot about these new challenges, and some of them are business-oriented. What do you guys think about marketing concerns for 5G? Is the big challenge going to be convincing consumers that it's worth paying more for so they don't just stay on 4G? Is it going to be to find those specific killer applications that will help you make more money because it will be clear to either consumer or business customer that they really are getting significant more value, but you've got to find those apps? Is it going to be how to actually apply that monetization? Because are you going to be charging more for latency or for bandwidth or for the different combinations? Is that the challenge? Or is it just going to be kind of a more general 5G is promising all of this value, and certainly for business customers, but even for consumers who you want to upsell, there's going to be SLAs that you're going to have to meet, and that means you're going to have visibility and the ability to measure and the ability to see where you stand. And it could be something else, but you don't get to pick something else this time. Okay, let's see the results. Okay, so that whole differentiation and monetization is as Itai has described, a challenge. It's a definite challenge, and it's still not clear where those services are going to be and how we're going to turn them into moneymakers. But clearly, granular visibility into what's actually happening in the network, which services, which users, which cross sections of demographics and so on are going to be critical, as well as the ability to measure the quality so that you can justify those plans as you roll them out. So Itai will now, address this whole issue of the applications that are driving the business model.
So just as you've indicated, new business models are indeed needed. And one of the areas that we've already seen operators embracing, it's just the beginning, but it looks that they are pushing towards this direction much more than they did in the past. It's value-driven application-based plans, which basically means that first, you want to increase your revenues, but you want to increase it in a way that is aligned to the increase in cost for providing such a plan. So, for example, if you can offer a cloud gaming plan that provides low latency for gaming, then this actually does not cost you a lot in terms of the network, but the price that you can charge the customer is very high. Mm-hmm. And what you need in order to do it is you need to identify the games, and you need to assure the low latency, which is assuring that the game messages will be the first to leave the network. Mm-hmm. These are mechanisms that can be done, and you can make quite a lot of money out of it. Second is plans like video, which we've seen in Netflix and we've seen in many other video providers, where if you want high resolution, you pay more than for a low resolution. And here, the network operator can offer an SD video plan, which is low rate. Mm-hmm. For example, $6 a month. I'm just throwing in a number there, don't kill me because of it. But if you want HD or Ultra HD, then for HD you will pay $15 a month, and for Ultra HD you will pay $20 a month. Okay. The cost here, the cost of delivering Ultra HD is higher than the cost of delivering standard definition, but you get much better price, much better revenues for it, so the return is still worth it. The key here is that in order to deliver such plans, you need to be very exact with your DPI. It's not easy to identify a YouTube HD movie. It's all encrypted. It's varying in throughput. You cannot just measure the throughput or the bandwidth consumption. You need to understand your material, and you need to be able to measure the QoE and to assure the QoE. Otherwise, you'll get a subscriber that paid for Ultra HD video, but is getting 480p. That will not work. Okay. And the last challenge we mentioned, if you recall, is the security challenge, mainly the new security challenge that the mobile edge compute is bringing. And over here, in order to protect the mobile edge compute, you need an inline high-capacity device that can protect a 5 gigabit capacity mobile edge compute against 200 gigabit or maybe even more capacity of attacks, and it has to be with very low footprint. The reason it needs to be inline is because these attacks are mostly hit and run that will simply kill the firewall and kill the entire mobile edge compute. So a 3 minutes attack will cause a 4-hour disruption. And this is another one of the solutions that Allot provides. Okay. And on top of, you also need a new approach to DDoS. It's not just an inline DDoS, but it's an inline DDoS that while the attack is happening, you can still assure the quality of experience of the applications running, and you can still provide an acceptable level of services to those customers that pay for it, even before you start mitigating the attack. So you need to first prioritize and provide QoE, and once the attack is detected, which we all know can take 15 to 30 seconds, but once the attack is detected, only then start the mitigation. Okay, Michael, what was yours?
Okay, so I think we've heard a number of interesting perspectives on 5G, on the challenges that we strongly believe are still going to be there despite all of the bigger, better, faster, and in fact some of them are because of the bigger, better, faster, like the transport costs and like the DDoS vulnerability. So this slide is a combination commercial, if you will, but also a question out to you. What we've heard about is mostly things related to the right-hand side of the slide. As you're looking at it, our smart solutions that give you visibility, traffic management, monetization through policy charging and control, those kinds of topics that have to do with really seeing what's happening in your network and managing it better, which is valid for 4G, is valid for 5G. And as Itai described, it will become critical for delivering on the 5G promises. There's a whole nother side here. We touched on the DDoS security, which is a network issue, but there are all kinds of other security issues out there for the individual users. And a host of solutions that we have to secure your mobile devices, to secure your home smart connected devices, and your IoT devices. And really what I'm asking here is some guidance from you all about what you'd like to hear about in the coming webinars as we build out our schedule for 2020. And you can answer that either on the right-hand side in that contact email or through the Q&A. It's not really a question, but it would be nice to hear from you. And that is pretty much it for today. So I hope this was educational, and the questions that we didn't get to, we will get back and answer them offline. And I encourage you again to use the links in the resources or at the link at the bottom to access additional information on 5G or any of these other topics that might interest you. Thank you all for participating, and we'll look forward to the next webinar. Thank you.